3.20.2, 1.9, 2.19 point something, 0.1 probably, 0.3, yeah, 2.19.3, and then, yeah, this stream's gonna be less than an hour, and then also 2.19.5, and then 3.20.3. Okay, let's find the maximum of the real value function exponent z over the closed. You back? Yes, I am. Welcome back to the stream, Zaya. I think that's how you say your name. Are you Muslim, by the way? You're from Indonesia, right? Oh no, that was somebody else. But yeah, if you're Muslim, assalamu alaikum. If not, hello, welcome back. This is the closed disk centered at 0 with the radius r. The closed disk of the radius r being greater than 0, centered at 0 in the complex plane. Alright, so we're trying to find the maximum. Find the max. Cow, Oz. Oh yeah. Australian. So, the function exponent z is entire, thus the absolute value of that attains its maximum over the closed disk with the radius centered at 0 at one point z0 on the curve radius centered at 0, the boundary circle of the disk, or the maximum modulus principle. To find the maximum, we consider maximum modulus principle, the boundary circle of the disk. Max is on boundary circle by max modulus principle. Okay, and then to find the maximum, we consider the modulus at the polar z equals re I theta on the boundary of the function of theta being in 0 to 2 pi, and apply calculus to find the location of the maximum, then compute the value there, and then that's a lot of gibberish. Let's tell chat to do it. Do 2.19.5. 0.3, my bad. That means absolute value of z means r. This is step 1. Step 2 is to parameterize. So we get r e to the I theta. Sorry, I put that r e to the I theta equals z. So we get it into polar coordinates in 0 to 2 pi. Compute the modulus. So how do we compute this? Right, so we have the exponent z equaling to r e to the I theta. Both in absolute values. So if we rewrite it, we get this r e to the I theta inside z, have exponent r e to the I theta here, and e to the I theta, right, by Euler's theorem. Hello, assalamu alaikum, wa alaikum assalam wa rahmatullahi. Where are you from? I'm from California. Oh yeah, welcome back, just sad. So, yeah, Euler's theorem over here, right? We get cosine plus sine, I sine theta, or multiplying. But, yeah, we basically, is it multiplying or plus by the Euler's theorem? If we rewrite it. I mean, because here it says we're multiplying, but also has addition. Like, that's so weird. Hello. Hi, Kick the Rock. Oh my gosh, I used to kick rock so much too. Welcome back to the stream. I mean, not back, but welcome to the stream. What are you doing? I'm doing complex calculus. I mean, complex variable. Complex analysis. I'm losing it, man. I don't have that much time. I only have like 40 minutes to do 3 questions. And they're pretty long questions, so pray for me. So we have cosine r e to the I theta times sine, or was it I sine? Well, it's not r e to the I theta because we're doing e to the I as cosine and sine. So what would it be? It would be exponent r cosine theta times exponent I r sine theta. Bro, I love gel pen. Gel needle pen. Yeah, it's really nice. Oh, dang. But yeah, how's it going, Kick the Rocks? Hope you're doing good. So if you take the modulus of this one, basically absolute value, you left without the I, because that's just like a negative 1 root. So you have exponent r sine theta now. Which equals to 1. I r sine theta equals to 1. How is that equal to 1? Can someone explain? Exponent sine theta equals to 1. How did exponent I r sine theta equal 1? And also, isn't Euler's theorem cosine plus I sine? Why is it multiplication now? I'm forgetting 2 identities. So Euler's formula is e to the IA equals cosine A plus I sine A. So then, when you have an r sine theta, then sine squared plus cosine squared it becomes 1. But then why is it cosine squared? Because I sine is cosine? Bro, okay. Why is... How did it become cosine squared? So the modulus is like squared terms in the inside. So that equals 1. Okay. Exponent r e to the I theta becomes how do you become cosine and sine? Oh, e to the I. Oh yeah, cosine. So you're taking an exponent of an exponent. So this is like e to the r e I theta. E to the e. That way you can have if e to the I by Euler's theorem is cosine plus I sine, then because it's an exponent, you could do multiplication in the middle. So you're doing exponent r cosine theta plus exponent I sine theta times exponent I r sine theta. So then you're still taking the modulus of this, right? So we're doing the modulus here. Then you get this squared plus that squared. Actually, no, it's not the whole thing. It's like each one separately. Hi guys, yo Killer, welcome back, and hi ZV Gaming 97. How's it going? Welcome back, guys. It's pretty confusing. A lot of exponents, easy to get messed up here. So we're gonna do this again, just because it's really confusing. So exponent z is equal to r e I theta. For z, so we have the exponent of r e to the I theta. So r e by Euler's theorem is cosine theta plus I sine theta. We also have the r, so we have r here, and we have r here. So this is still exponent, but this is exponent modulus, right? Forgot this. So then we're doing the modulus of the exponent of our cosine theta plus the modulus of our I sine theta. So r e to the I sine theta. E to the I r sine theta. Oh, we're still taking the exponent, by the way. This is exponent plus exponent. So if we do the Euler's theorem again, then we have exponent z equals to exponent r e theta. Man, I'm getting confused. I won't be talking so much because I'm doing my boring homework. Okay, me too, by the way. It's so boring. It's so confusing too. Your exponent r e to the I theta is actually r cosine. That part I get it. That part I did. That's where I'm at. But if you take the modulus of this one right here, take the modulus of this whole thing, exponent r I sine theta, what does that become? It becomes 1, but how? We have cosine squared r sine theta plus sine squared r sine theta, whatever, exponent r I sine theta, r I sine theta. By Euler's theorem, it's cosine plus I sine. This is just whatever's on the inside. That equals 1. We don't have to care about that too much. R I sine theta. It just becomes 1 by Euler's theorem, whatever exponent it is. If you take the magnitude of sine, it becomes 1. Does that make sense? Cosine theta equals 1 when theta is 0. So its largest I'm almost done though. Lucky. It's nowhere near done. I have like 27 minutes. And it's so confusing. It is 1. So exponent z. Okay. So if that equals 1, then we're still multiplying. I mean, not in the here. Oh yeah, we're still multiplying. So we have exponent r cosine theta times 1. So that's our maximum. So exponent z equals to exponent r cosine theta. So if we would we computed the modulus. That's what it is. Cosine theta. And then this is largest. So the highest cosine could go is 1 when theta is 0. Largest when cosine theta equals 1. So theta equals 0 that time. So the maximum exponent z is exponent to the r, e to the r. Where r is less than or equal to z on the positive real axis. Because the boundary, the max modulus principle says that r, that the magnitude of z is r. It's on the rim, on the positive real axis. So the max of z is less than or equal to r. Max of exponent z is equal to e to the r. Since f of 0 is exponent r equal to f2 pi, Okay, let's let her focus and not disturb her. Done too. Yo, congrats. Kitty. Yes, Luca, bro. So squishy. The squishmallow. So this is the answer, but I'm not sure how we got the answer. If cosine theta equals 1, wouldn't that be the... Anyways. So, r cosine, right? Your cosine is largest when it's 1, so really it just depends on the r, exponent r. Because cosine goes to 1. But if we... It's all about Euler's theorem for this question. Turning the exponent into cosine times I sine. Because it's an exponent of an exponent. So using the power, the exponent rules, and the Euler's theorem to get that. And then the f prime is negative r sine theta times the exponent r cosine. And so f is differentiable and continuous on 0 to 2 pi. As a critical point at theta equals pi because f prime of theta equals 0. Okay, that's the maximum. It's the top of the disk. So it just depends on r. Yo, I just want to spot, but bye. Gotta go. Okay, bye, Primo. Thank you for stopping by, and Catherine, welcome back. So I have like 22 minutes. I did this question. I'll just make sure to use the Euler's theorem and that for this. I'll get some partial credit. Say Euler again. Euler. 2.19.5. I gotta go. I got class. Okay, bye. Thanks for tuning in. You know for a fact that if Sagittarius A star wakes up, then we happy. Yeah, that's true. See you in maybe 30 minutes if you'll be live still. Yeah, I'll probably be done live streaming in 30 minutes. 22 minutes. So this question is about the new theorem, Liouville's theorem. We have to show that cosine z is not bounded on the complex plane. Prove that cosine z is not bounded. So we know that the function cosine z is entire, right? And it's defined by a power series with an infinite radius of convergence. So on the contrary, we're supposed to the contrary that cosine z is bounded. Then by Liouville's theorem, cosine z is constant and has the same value at every point. But cosine 0 is equal to 1 and cosine pi over 2 is not equal to 1, so that's a contradiction. So thus cosine z is not bounded function on z. Okay, so we're gonna prove this. Prove this by proof by contradiction. To prove that cosine z is not bounded. By the way, what's the profile you got there? Me? See, Euler. Euler? That's Euler? It's not Euler? Dang, like my professor says Euler. It's Euler. Oh, interesting. Thanks, cow. So, and this is proof by contradiction, right? So, by Liouville's theorem, cosine z is constant and has the same value at every point. Suppose it's bounded. What is Liouville's theorem? If a function is entirely bounded on C, then it must be constant. But we know that cosine z is not constant. Suppose cosine z is bounded by Liouville's theorem, it would be constant. But cosine pi equals 0, cosine pi over 2. Wait, I forgot. Cosine 0. Cosine pi over 2 is 0. And cosine 1, cosine 0 equals to 1. Oh, I'm cooked. I don't know my cosines. Cosine 0, cosine pi over 2. What is cosine pi? That's just me sleepy in high school. Dang. Okay. Cosine pi is what? Is negative 1. Cosine pi equals to negative 1. That, I think it's easier to remember, right? Pi, negative 1, 0 is 1. Because cosine is the x value. Alright? So, it's a contradiction. There you go. Proof. Done. But we have to remember Liouville's theorem. If a function is entire plus bounded, because cosine is entire, then bounded by c, then it's constant. That's easy. That's an easy question. So we're done on that question. For that, and then we have the last question: computing a Taylor series via the definition. So this is the last question. 320.3. Whew. I'm scared. We might need to take a break, guys. What should I draw? Draw an island of just freedom. Oh, that sounds like Epstein Island. Oh my god, astaghfirullah. Dang. It's just like my brain is hijacked by reality. I just want to be free from the shackles of life, that is exams. But yeah, draw like a pile of money and like just ability to go everywhere in the world. I don't have a black pen and marker for a void. Only Allah can test. Yeah. I draw like a nice village, like a German village of just happiness. And then draw me in it. I know I said German, it's just like those are the typical houses you see in like paintings and drawings. So, alright. For this question, should we do a Wordle before we start? One more Wordle. Please. Before we start. Oops. Gotta move this closer. And saying only interest to my teacher would only give me an F. Okay. Reach. There's no A, so this can't be reach. But I think to test out CH and the placement of R and the E is a good word to guess. Hi, Aston Dread. I have literally 15 minutes until I have to go take the exam. But we're playing Wordle. Priorities. Should I draw like a little island on the sea with a little palm tree? Yeah, go for it. Alright, C and R. Crib? There's no E though, that's like a waste of 2 spaces. Crust. Krusty Krab. Circus. No. How many minutes do you have left, Julia? 14. Burst. But there's a C. The first letter is C. And the R is either here or here. If it's here, we could say the word is curse. There's no U, there's no S, there's no E. But that would tell us if the R is here. I would say Caesar, but that's not a 5-letter word. Not cooler. Clock. But there's no R. I don't know what I'm doing. Crown. Oh, you guys are smart. Oh yeah, that's a good guess though. Dang, look at all that. It ends with R. Church. Circle. That's a 5-letter word. Croc. There's an N though. Crown was a really good guess though. Corns. There's no S. Corny. Hey, we got it. That's always satisfying. Alright. Look at those fireworks. Yay. See, small bursts of happiness gets you going. Alright. So, final question. Final push. And then it's doomsday. I can't believe doomsday is real. Like, we're actually gonna face Day of Judgment. And a lot of protagonists, I mean. I'm so scared, man. I can't believe death is real. I can't believe I'm gonna be eaten by maggots. And there's nothing you can do to stop it. That's crazy, man. What is analytic on the plane? G equals Z. Z not equal to 2I. So it's the same disk, I would say. Except the function is different. It's 2 plus IZ to the negative 1 power. So use induction. A equals 5I. Centered at A equals 5I. Taylor series. Build a Taylor series. You have an exam next in 40 minutes, yeah. I have to go in 10 minutes. Can I do it in 10 minutes? I don't know. I'll take more time if I need to. So, F0 of Z 1 over 2 plus IZ. We did this, right? It's pretty similar to the last question. That equals, when you take out the constant, 1 over 2 times 1 over 1 plus IZ over 2. And then then what? If we plug in this, now I'll have to make an LC with colors green, yellow, blue. You're exhausting your brain before an exam. I know. I wish I didn't have to, but this is the last question. You know, our professor, he does this too. Yeah, like on purpose, he exhausts our brain. .20.3 Taylor series centered at a equals 5i. Cleanly. Find the Taylor series. Now the Taylor series is not 0, so we write everything in terms of z minus 5i. So alpha equals to 5i, that's the center. So that's the same thing as saying z minus 5i. So if we rewrite the function around 5i, it's z minus 5i plus 5i. So you plug that in to 2 plus that times plus I times that. Plug into what? Oh, to f of z. So z equals z minus 5i plus 5i. And then you plug that into f of z. 2 plus I of z minus 5i plus 5i to the negative 1 power. Simplify it, then we get plus I times 5i. So the I goes to this and that, but we don't compute this part. We just do 2 plus I z minus 5i plus 5i squared, which would be negative 5, so this would be negative 3 plus I 2 minus 5i z minus 5i, my bad. And then this is still a negative 1, right, to the negative 1 power. So it becomes 1 over negative 3 plus I z minus 5i. So we factor to match the geometric series. Again, it's like 1 over 1 plus w, right? 1 over 3. Negative 1 over 3 gives you 1 over 1 plus 1 z minus 5i over 3. Why is it I? Oh yeah. Then you apply it to the geometric series, which is what again? What's the geometric series? N equals 0 to infinity, negative 1. I forgot the rest. No, it's just 1 over 1 minus w equals w to the n. That's the geometric series. Oh, what about the negative 1 though? Assalamu alaikum Joy. Wa alaikum assalam wa rahmatullahi Abdul Khaliq. Rabbi zidni ilma. Yeah, sure. Yeah, of course. You should pray before it and rest a little bit before the exam. Oh, don't worry, I prayed. Prayed Dhuhr, but the geometric series is negative 1 to the n. Why is this one not negative 1 to the n? And why is it 1 minus w? So that's our geometric series. If we plug in this is w, right? By the way, I like to make drafts a lot about drawing and crafts. I just made the sketch of my OC. Awesome. Rabbi zidni ilma. Yeah. Okay. So w is that. W negative 1 to and iz minus 5I over 3 to the n. That's our series. Hope that's okay. Oh yeah, don't forget the constant with that pulled up. Times negative 1 over 3 as well. Just throw it in there somewhere. But why? I don't understand why, like, this is just another repeat of the same, problem as the one before it. But I don't get why the end part changes. I have 3 minutes, don't worry. But, let's see. Why is there no negative 1 to the end for this geometric series? Which geometric formula are you using? So if it's 1 plus w, then you add the negative 1. If it's 1 minus w, there's no negative 1. That's simple. There's 2 you should know. So 1 minus that. What? I got 1 plus that. A negative 3 plus. They just factored out the negative. Oh, you have to. So that becomes 1 plus w. That was a negative. So if we do this wn, there's no need for this. So it's even simpler. It's just that. That makes a lot of sense. Okay. 1 minus that. And then we get what answer? We get this right here. This answer, which I got right here. Negative 1 over 3. Yep. That checks out. And then you just apply the end values and compute it. It's really hard to compute. They just left it like that. But the radius of convergence, how do you do it? 2 plus iz. 2 plus iz right here equals 0. You solve for z. How do you do the radius part? Solve for z. And then for z we have, what's it called? Z equals negative 2 over I. I just got the OC Life. I tried like a space game. Cute. Where's Tofu? He was here earlier in the last stream, but I think he had to go. It's pretty early for him. It's like 2 a.m. for him. So it's negative 2 over I. Solving for z. It's a singularity. Z equals 2i. Actually, z is just 2i. Yeah. If we solve for z. So, 5i. Where's 5i? Distance from the center. Five I minus 2i equals 3. 3i modulus 3. That's our radius. Domain and disk. So the disk of convergence. The center is at 5i, right? Because they gave that to us. A equals 5i. So if we have 5i as the center, and it's a disk because it does not reach 2i, it's bounded, and the radius is 3, then we could draw it very easily. And yeah, how about Sailor Moon? Sailor Moon is cute, but yeah, I think I'm ready for my exam now. Thank you guys so much for watching. I have to go now. Thank you so much. Bisna, not Bisna. Assalamu alaikum. You can tell I'm nervous. Okay, bye guys. Thank you so much, by the way.